Hello subscribers and guests of the channel. This is lecture number 5, I believe, on our mathematics A-level and AB course on integration. Initially it was supposed to be a lecture on integration by substitution. However, I've had some requests to do the definite integrals, so we will do that first, and then next lecture will be on integration by substitution. So let's start. My paint is as usually prepared, and let's begin. So what is defined or definite integral? Quite often you will see an integral sign. Let me just put it a bit bolder. So quite often you will see an integral sign with some numbers above and below. So what does it mean? For example, we have integral of, let's say, 2x dx, but with numbers 3 and 5 above and below correspondingly. So how to approach that? Well, this is definite integral, and first we need to solve it as a usual integral. So we lift the power of x to make it from x power 1 to x power 2, and then we divide 2, which is in front, by 2, making us 1. And there is no need for a c here, so no constant. So the result of such integral in its indefinite form will be x squared. However, because we had numbers, we should continue. And after we get solution for the indefinite integral, we should put those square brackets and then write 3 and 5. Here the same, 3 and 5, the boundaries. So these numbers are called boundaries of integral. And how to apply them? Well, first you stick the upper boundary. So you get 5 squared, and then you stick the lower boundary, minus 3 squared. And the result will be 25 minus 9. And that will be therefore 16. So 16 is the value of this definite integral. Every definite integral is a number. Let's make one more example. Let's solve it. So for example, you have integral of, let's say, 1/2 x power 3 plus 2x. And then this all is dx. And the integral from, let's say, 1 to 2. How to do that? As usually, we have a right to break it into two integrals. So first we integrate the 1/2 x cubed dx, and then we integrate 2x dx. And boundaries we keep as they are, 1 and 2. Therefore, we will get from the first one, it will be x to power 4, so x power 4. Then 1/2 divided by 4, it will be 1 over 8. And then plus integral from 2x we have already solved before, it is x squared. And then we can unite them and put those brackets from 1 to 2. Again, no constant. After this is done, we can plug in first 2 into every x, and we will get 1 over 8, 2 power 4 plus 2 squared, and then minus, we plug in 1 here and 1 here. So 1 over 8, 1 power 4 plus 1 squared. And then it will be 2 power 4 is 16, 16 over 8 is 2. So 2 plus 2 power 2 is 4, so 2 plus 4 minus. And here we will have 1 over 8 plus 1. 1 over 8 plus 1. After opening the brackets, or actually here there is no need to open the brackets, we can calculate it straight away. So it will be then 6 minus 1 over 8 minus 1. So it will be 6 minus 1 is 5 and minus 1 over 8. 5 minus 1 over 8. And that will be either 4 and 7 over 8. Or you can say it in improper fraction. 32 plus 7, 39 over 8. And that's done for this definite integral. Now moving on to the geometrical sense of these definite integrals. Definite integral is the area under the curve. So for example, you have the curve f from x. This is f from x equals y, so y equals something. Let's imagine it is y equals 2x plus, let's say, sine x. Let's just imagine that. And you need to calculate definite integral of that 2x plus sine x dx from 1, let's say, to 3. So that will be 1, that will be 3, and the result, the value of this definite integral, will be this area under the curve, so between the curve and x-axis. Let's just calculate this integral, assuming that 3 is in radians. So x is given in radians. There will be another lecture on what is, like on how to calculate something in radians, how to calculate it in degrees, and what are those radians. So in this case, we will solve the integral, which will be x squared, like before, but integral of sine will become minus cos x. So it will be minus cos x. If you don't know how to do trigonometric integrals, there is also a lecture on that. So x squared minus cos x. And again, from 1 to 3 boundaries. Then I will put first 3, it will be 3 squared minus cosine of 3 radians, and minus 1 squared minus cosine of 1 radian. 3 squared is 9, so it's 9 minus cos 3 minus 1 plus cos of 1 radian. 9 minus 1 will be 8. And then, since these are cosines of two different angles, we'll have to calculate them by calculator. For now, I can write plus cosine 1 minus cosine 3. And then I can take my calculator. I would advise everyone to have this kind of calculator for your A level. If it is IB, it should be Texas Instruments, but for A level, this one, Casio FXCG50 is the best. So I'm switching everything to radians from degrees. And then I'm putting cos 1 radian. It will be 0.54. So 0.54. And then cos of 3 radians. Then will be minus 0.99. So this will be minus 0.99. So it will be then roughly 8 plus 0.54 and minus, let's already plus, because minus and minus give us plus, so plus 1. So roughly 9.54 will be that area under the curve. So we can write it 9.54. Sometimes, however, the area can be below x-axis because the function is below x-axis. And in this case, our result will be negative. Let's have a look at it. So, for example, you have a parabola y equals x squared and maybe, well, let's say minus 2x. And you need to calculate the area, so you need to integrate it from x squared minus 2x dx. So you need to find the area from 0 to 2. Let's do it. Integral of this function will be 1/3 x power 3 and then minus 2. No, already no, not 2 because we have integrated minus x squared and boundaries between 0 and 2. So how much will it be? First, we need to substitute 2 and then we need to substitute 0. By substituting 2, we get 1/3 times 8 and then minus 2 power 2 is 4, so minus 4, like that. And when we substitute 0, we get 0 minus 0, so it is 0. Then how much will it be? Well, it will be 8 over 3. This is supposed to be 8. Minus 4. 8 over 3 is below 3. So the result for 8 over 3 minus 4 will be negative. Minus 4 over 3. Then the question is, how can the area be minus 4 over 3? Well, the area cannot be, but the result of the integral is correct. Because the parabola between 0 and 2 is somewhere under the x-axis. So if we solve quadratic equation, x squared minus 2x equals 0, it will be x minus 2 equals 0, so x will be 0 or x will be 2. So parabola looks like that with roots of 0 and 2. So in this case, actually let's put 0 to this side. 0 and so in this case the area between 0 and 2 will be between the function and x-axis still, but it will be below x-axis, and that's why the result is negative. So if we have such situation, we can just say that this area is 4 over 3. You can ignore negative sign. Negative sign in integral tells us that the area is above the curve and below x-axis. And now final words on when you cannot just calculate the definite integral and find the area like that. Well, the first case is when the function is broken. For example, you have a hyperbolic function from here to here like that. It is y equals 1 over x. If you want to calculate the area, so let's say integral of 1 over x from minus 2 to 3, you cannot do it because minus 2 is roughly here, 3 is roughly here, but the function is not continuous. It has a vertical asymptote, and then you cannot do anything with it. I mean with this integral. There are ways how you can do it, but it's already a completely different story. The second case where you need to be attentive is when the function goes through 0. Let's take already a known function y equals x squared minus 2x, and let's try to calculate the integral between, let's say, 0 and 4, x squared minus 2x. Well, we already know the result for the integration. Result for the integration will be 1/3 x cubed minus x squared. So it will be then 1/3 x cubed minus x squared. And at the first glance, nothing prevents you from putting here 0 and 4. You can even put here 4, and you will get something like 4 power cube over 3. So that will give us 21 and 1/3, or 64 over 3, minus x squared, so minus 4 squared, minus 16, and minus 0. So the answer will be okay. It will be then maybe even positive. Yes, indeed. So it will be roughly 16 over 3. But it will not correspond to the area under the graph. And the answer is because parabola looks like that. And if we integrate it from 0 to 4 somewhere here, we will get that red area. I said red here with positive sign, and this area with negative sign. So that will be negative, that will be positive, and hence they will cancel out or subtract one from each other, one from another, and therefore 16 over 3 will be not a correct answer for this total area. In order to solve that correctly, we will need to break the function into two pieces and find first integral from 0 to the root, in this case 2, and then plus integral from 2 to 4. And you will see, if you do it yourself, that the result is different from 16 over 3, because that will be negative. To find the area, you will take the opposite sign, and that will be positive. I hope you've enjoyed this explanation, and I helped some of you to get better marks at the upcoming tests at school. Have a nice time. See you soon with the integration by substitution, and see you. Bye bye.